Question 3, we now have a piecewise function and a table for g of x that is one of the pieces in the function. And it tells me the temperature of a room in Fahrenheit degrees can, on certain days, is modeled by f of x. Above where g is differentiable, that will matter whether it's differentiable or not, is differentiable, a function on t, as t is measured in hours, and the values g of t are selected in the table. According to the model F, what is the average rate of change of temperature of the room from 0 to 12 hours? So that's basically using the table. So the average rate of change is using the slope formula. Now I'm not using an estimate. This is an equal sign here. This kind of looks messy, I'm sorry. But it's not asking for you guys to approximate the instantaneous rate of change. It's saying just find the average rate of change, which means that it's going to be an equal sign. If I'm going to put it in words, which is coming next, so I might as well practice that. It says you can write it in two ways. The average rate of change in temperature of the room over the interval, oh, I forgot, I think I erased the interval here, over the interval 0 to 12 is negative 11.6 Fahrenheit per hour. Or in better context might be the temperature, the room temperature in the room is decreasing at an average rate of 11/6. But if I use the word decreasing, you should not, it already takes care of the negative, so you should not be writing a negative out here in front on the interval from t's between 0 and 12 inclusive. Part B, the data in the table, use the data to approximate. So now we need an approximation symbol because we're now approximating the average, or not the instantaneous rate of change at 10. And I'm going to use 2 points surrounding the value 10. So that's going to be those 2 points there. Substitute in the values. You can stop right here. You don't have to simplify, but if you do, great. And if I'm going to write it in context, it's going to say here, the instantaneous rate of change of the room temperature at t is equal to 10 hours is approximately, you got to use the word approximately, negative 11/8. So I'm saying it's Fahrenheit per hour. Or you could say the room temperature is decreasing at approximately 11. When I'm using the decreasing, we're no longer then using a negative to describe the rate. Again, now, Part C is probably, I should have left some more room here, but it says if f is f continuous on the interval from 0 to 24, justify your answers. Now, there are 3 distinct things we need to establish. We need to establish that each of the pieces in the piecewise function themselves are in and of themselves continuous. And then we have to check where the 2 pieces meet. Are they? So it's not, you can't just say, you can't just do the part where they meet. You have to also make it clear that I know that g of x is continuous on the interval that's given. And the reason why I know that is because it's differentiable. So you have to mention that g of x is differentiable on the interval from 0 to 12, which implies that it is continuous. I'm reading this because my handwriting is so bad, right? So that needs to be part of it. The second portion of it from 12 to 24, we know is continuous because that piece is a polynomial. So, and all polynomials are continuous everywhere, so that means it's also continuous on that interval. So now that we've established that the 2 pieces are continuous, then we have to show where do they meet. Are they continuous where they meet? And that's how you do the left derivative, the right derivative, not derivative, the left limit, the right hand limit at 12, and the value. You have to have all of those 3 things and then show that the limit from the left is equal to the value at 12 and the limit from the right are all equal. And therefore now I have all of the pieces, the 2 pieces themselves and where they meet are going to tell me that it's continuous. So here I wrote a little summary of what needs to be done. You must show both pieces of the function are continuous and show where the pieces meet is continuous. So those 2 things have to be covered. Just as if there were 3 pieces, you have to check all of those spots. They're not going to do that, I don't think. All right, find f prime at 20. the instantaneous rate of change in temperature of the room in Fahrenheit degrees at time is equal to 20. So I'm going to establish that the derivative on the interval from 12 to 24 is the polynomial part. So you just take, so I wrote, it's not true that f prime of x is equal to t over 4 minus 3 at all times. So that's why you have to add that it's only on the interval from 12 to 24. So be really careful. That needs to be included in there because it's only true on that interval. It's not everywhere. And then I substitute in the 20. So it's not enough just to say the derivative is t over 4 minus 3. You have to include the interval there. When t, and then if I was going to put this in Word, they've already done that, but just getting ready for Unit 4. When t is 20 hours, the room temperature is increasing at a rate of 2 Fahrenheit per hour, 2 degrees Fahrenheit per hour.